Good afternoon, student. Today's practical is experiment number 8, that is last practical of the analog electronics 2 for the 5th semester. Now the practical title is design a square and triangular wave generator using IC 741 for F0 is equals to 2 kHz. That means we have to generate a square wave and triangular wave of frequency of 2 kHz with the help of 741. Now component or apparatus required for this experiment are simple breadboard, well power supply, multimeter, CRO and resistor and IC 741. That we are required here two IC 741, because we know that in 741 only single operational amplifier is available. That's why here we required a two IC of 741. Now in theory lecture we had learned about how to generate a square and triangular wave with the help of 741. For that, we have to design first comparator, and the output of the comparator will be provided to the integrator circuit. Now that theory part we already covered in the lecture. Still I am going to explain some part of this experiment or circuit of this experiment. Now this first circuit, that is this operational amplifier R1, R2, this circuit is nothing but the simple comparator, where inverting terminal of the operational amplifier is grounded. That means this voltage is nothing but the zero voltage, and the reference voltage will be provided to the positive terminal through R1 and R2. That means this will provide the reference voltage. Now when the reference voltage is below and above the input voltage, accordingly this output of the first operational amplifier vary, and the output of the first operational amplifier simply plus minus Vsat. Depending on the supply, we are getting a different voltage. If we are using 15 volt, then definitely we are getting plus minus 14 or plus minus 13 volt as an output. So this circuit is act as a simple comparator. The output of the first circuit, that is square wave, because here only two level will be achieved, that is plus Vsat and minus Vsat. So simply we are getting a square wave. This square wave will be provided as an input to the second operational amplifier, and this second operational amplifier circuit is nothing but the simple integrator circuit. Now we know that when we are providing a square wave as an input to the integrator, we are getting a triangular wave with same frequency. That means frequency of the first and frequency of the second wave, that is square and triangular wave, is same. Only difference may occur in the amplitude of the square and triangular wave. So this resistor and capacitor are nothing but the component of the second circuit, that is nothing but the integrator circuit. The same circuit will be implemented on a breadboard with the help of R1, R2 and two operational amplifier and R and C. The same circuit is made on breadboard. Here are the connection for the second circuit. Here we are using two operational amplifier and resistor and capacitor circuit, and we are providing a supply of plus minus 15 volt from here, and we are taking output on a CRO with the help of pin number 6 of the both operational amplifier, that is operational amplifier 1 and operational amplifier 2. So for the first operational amplifier we are getting this output, that is nothing but the square wave output. This is nothing but the square wave output of the first operational amplifier, and the second channel we are taking the output of the second pin number 6, that is nothing but the second operational amplifier, and we are getting a same triangular wave. Now if we look at the both wave, we are getting a same frequency. So you can just calculate the frequency. Now here this is nothing but the square and triangular wave output from operational amplifier. Now you can calculate the frequency with the help of TB and this division. You can simply measure this division and multiply with this TB, that is 0.1 millisecond, and you will find the frequency. So this is what the output of the operational amplifier 1 and 2. The first output, that is square wave, is first operational amplifier output, and triangular wave is nothing but the output of the second operational amplifier. In this way we are demonstrate that we are obtain or we are design a square and triangular wave generator with the help of operational amplifier. Now if you see the observation table, in observation table we have to just note down square wave amplitude and its frequency and triangular wave amplitude and its frequency. So this is nothing but the observation table for the last experiment, that we have to note down the amplitude and frequency of the both wave. And one more table, that is design table, we have to write down, that is design value. We are getting a design value of 40.6 kilo ohms. So what is the selected value, vagera, that also we have to note down. So this is what the last experiment related to the analog electronics 2. So thank you very much for attending the practical of analog electronics 2. Thank you once again.